So ionic formulas and ionic naming gets a little bit more challenging when we incorporate polyatomic ions and metals that have more than one charge or more than one oxidation state. So polyatomic ions, as the name implies, poly meaning many, are ions that are made of many atoms. Now, internally, these ions are held together by covalent bonds, but externally, they actually end up having some kind of imbalance of electrons to protons, and so they end up with an overall charge. So it's kind of like a charged molecule. But in this context, it ends up bonding to other ions through ionic bonds. So we just need to know their formulas and their charges and their names. I say just, obviously that's kind of a lot of detail. Thankfully, the IB only really requires you to know 7 of these things by heart. There are many more, so they could have made the list more extensive, but this is a list of very common polyatomic ions, and they probably sound kind of familiar. So you've got ammonium, NH4 plus is the only positive one to know. There's 3 different 1 minus ions, so OH minus hydroxide, NO3 minus nitrate, and hydrogen carbonate is HCO3 1 minus. You've got sulfate and carbonate, the 2 minus ions, and phosphate, the 3 minus ions. Remember that when you write a charge as a superscript, the number comes first and the sign comes after. But when we describe them as oxidation states, then we write +1 and we write -1 and we write -2. And so while charge and oxidation state are almost the same thing, they do have some slightly different conventions. Okay, but once we know that we have that charge, then they're pretty straightforward to use. So for example, if I had calcium hydroxide, calcium forms a 2+ ion and hydroxide is a 1- ion. So I need to balance this with the crisscross rule. So I need 2 hydroxide ions. But in order to show 2 of this whole hydroxide, the way I do that is by, I use parentheses. So I write this and I write OH and I put a 2 down here. I'm not going to include this 2 anymore. And this would be the formula of calcium hydroxide. So if you need more than one of a polyatomic ion, then you put it in parentheses to show that you have more than one of the whole thing, not just doing something like that, which would imply just 2 of the H's. Or if you wrote like that, it would kind of imply that the O's and the H's are not connected necessarily. So by keeping it together, OH in parentheses, it's clear that OH is sort of its own unit, its own ion, hydroxide, and the 2 on the outside tells you how many you have of it. The other thing to keep in mind is that we have these metal ions that can have more than one charge. Now, traditionally, these are sort of transition metal ions, so things like copper and iron. So a property of transition metals is that they have more than one stable oxidation state, which we've talked about previously. So some common ones that get used are copper, which forms both a +1 and a +2, and iron, which forms both a +2 and a +3. But there are a couple others that aren't transition metals. They are actually in the P block, but they're further enough down the table that they have some different properties than those at the top. So tin and lead are very common to be used, and tin and lead both form 2+ ions, and they also form 4+ ions. So how do you know which one? Well, you're not really expected to know which one it will form or which one it's more likely to form, but you should be able to either figure it out from a given formula or figure it out from a name. And so you'll notice that in these ions, where they have more than one possible charge, that charge is indicated with a Roman numeral. That is the convention. And so that Roman numeral is called its oxidation number. It's basically its oxidation state or its charge. So when naming something that has a copper 2+ ion in it, you have to say that it's not just copper something, it's copper 2 something. So for example, copper 2 sulfate is a very common compound to talk about on the IB exam. So if you're very quickly mentioning it, you might just say copper sulfate, but really more correctly is to say copper 2 sulfate. And that is telling you that the copper is in its 2+ form as opposed to its 1+ form. There are other metal ions that they use a lot on the exam, and they're basically going to expect you to know these. So it's helpful to add them to kind of your list of things to memorize, like along with the polyatomic ions. Especially silver and zinc come up a lot. So silver forms a 1+ ion only, and zinc forms a 2+ ion only. So I don't need to say silver Roman numeral 1 anything, because silver only forms 1 charge, so that Roman numeral is not necessary. Same thing with zinc. You don't say zinc Roman numeral 2 anything, it's just zinc. Okay, and then so here are just a couple of practice. So for example, if you're given this name, you can then figure out the formula because they've told you the Roman numeral 2. So you figure out that tin has the symbol SN, and the 2 tells you it's tin 2+, and then it's with hydroxide, which is OH-, again, a memorization thing. And now I can tell that I need 2 hydroxide ions to balance out the tin. And so my final formula would be SnOH2. So that one sort of combines all the different tricky details. It's a metal with more than 1 charge, it's a polyatomic ion, and you have to put the parentheses around the OH-. The next one is if you're given a formula, you should be able to figure out what form of copper you have. So I know that O is 2-, so what charge must the copper have for this to be balanced? Well, there's 2 coppers balancing out this one O2-. So each copper must just be a 1+. So you kind of undo the crisscross, if you will. So this is copper 1. And so this compound is called copper 1 oxide. Okay, so not copper 2 oxide, that would have a different formula. This is copper 1 oxide. Okay, and so now we've got a whole page full of practice.